Hi there, and congrats on making it to the end of the SOLIDWORKS class. This week is the last new content that we're going to be covering. In your text, we're looking at how to create assembly drawings, which is really important. Need to be able to put together our parts as we've been doing, and then make drawings of those so that we can generate bills of materials and things like that for complex assemblies. Your book does a great job walking you through that process via the tutorial, so I'm going to leave that content there for you to digest. And what I want to spend this time with this week on is actually exposing you to some of the additional functionality that's within SOLIDWORKS that's going to be really useful for you as you continue your studies. So the first thing I want to look at is what's the simulation tools within SOLIDWORKS. With the education version you have access to both Simulation Express as well as the full suite of simulation tools in SOLIDWORKS. This is a pretty expensive package if you're to buy the professional version of it, and allows you to do all sorts of different simulations on parts, including compressible fluid dynamics, heat transfer, vibration analysis, basic stress analysis, and things like that. All SOLIDWORKS packages come with the Simulation Express, which is a more basic version of those, and that's what I'm going to show you today. To access the Simulation Express tools, you can come up here to Tools, and at the top of the list is the Simulation Express. Okay, and Simulation Express walks you through the different settings, and I'm going to go ahead and switch this to English because this is an English part. I'll say OK. And we can just walk through what we need to do to set up a simulation. The first thing I need to do, I suppose, which I should have done earlier, is to assign a material. So I'm going to right click on my part, edit material, and I can choose all of the kind of standard materials that are within SOLIDWORKS, and I'll go ahead and use ASI 304, and then I can close this. Okay, so I've assigned some material properties to my part, and now I need to add a fixture. So what this tool is going to allow us to do is to look at the stresses with a part given a basic load. And so you have to choose areas of the part that are fixed, meaning they're going to be held in place, and then where your loads are going to be applied, and this will create a stress plot for you. And I'm going to go ahead and just select that maybe that this surface and this surface are going to be fixed by the fact that I'll put a bolt with a washer on it. Now if I really wanted to do this precisely, I could split this surface into a donut or annular shape around the hole to kind of be the shape of a washer. For a very rough estimation, I can go ahead and just fix the whole surface there. Okay, so I'm fixing that surface in place. And the next thing I'm going to need to do is add either a force or a pressure. So let's go ahead and add a force. And I'm going to go ahead and not add it to those faces that I just fixed, but instead add it onto this face. And you can see that you can choose to either put the force normal to it or in a selected direction. And I'm going to go ahead and use a selected direction. And I'm going to choose a plane to make that force normal to, which is the top plane. All right, so now you can see the little purple arrows there are pointing in the direction of the force, and I have to give it a value, and I'm going to say maybe I put 50 pounds of force on this. Okay, go ahead and hit check. I now have both a load applied, my force, and I have the fact that this is fixed in place by these two planes. All right. If I continue, I've already done my material. I went ahead and did that. So we'll go ahead and we've already applied. We can go with alloy steel. I'm going to go back to my 304 and apply that and hit close. Okay, so it adds Young's modulus and the yield strength, both values that you'll become familiar with as you continue on in your education in mechanical engineering. Once I'm done with that, I can go ahead and run the simulation. Now what SOLIDWORKS has done is it actually splits this part into a bunch of different pieces and or what we call elements. So it makes a mesh or a network of different I'm going to stop the animation here because that's a bit distracting. A network upon which it can write a bunch of equations. Okay, and what it does is it solves deformation and stress equations all across each node in this part. It's called finite element analysis. And we can say, yes, this deforms as we would expect, and so we continue. And what it's going to do here is it will now be able to plot for me. I'd like to see the von Mises stress, which just shows you a stress distribution across a part. And you can see where the points of highest stress are. They're down here. And I would say actually this is likely due to the fact that our element size is a little bit too large. But what SOLIDWORKS is able to do is give you plots for how the part would deform and then a value for what stress would be the peak stress. And you can compare that to see whether you go past the yield stress. And in this case, we don't, so the part would be functioned properly. I want to show you this tool, but I also want to give you a giant caveat that you really shouldn't use this tool until you can do these calculations by hand. The saying garbage in, garbage out certainly applies here. If you don't do your fixturing properly, or you don't apply your loads properly, or you don't have a fine enough mesh, you're not going to get the results that you think. And I just want to make sure that you understand this is just to show you what you can do in the future, not what you should be doing right now. All right? A couple other tools we'll look at in another video, sheet metal, as well as a few others. So stay tuned.